Good to go? All right. Thanks to those who stayed after that awesome panel. I mean, geez, 10, 20, 30, this guy, 40 years in the industry doing this stuff, that's crazy. I can't even, it's hard to think what 2 years is going to look like, let alone 30 years from now. Thank you again for staying. For some quick introductions, my name is Adam Horn. I'm with HNTB. Myself and David, who I'll let him introduce himself next. We work at HNTB. If you're not familiar with that, we are a large architectural engineering and consulting construction firm focused on infrastructure, so roads, bridges, airports, rail, even some sports, professional and college sports stadiums as part of our architecture group. I lead a team around virtual design and construction, which includes design applications, also AR, VR, XR, 3D, 5D, X, all that stuff. So that's who I am. I'll hand it to Dave for a quick. Oh, you got it, Mike.
Yeah, Dave Willard, welcome everybody. I work with Adam underneath his team as the VDC real-time lead. That's basically a fancy title for I help create all of the real-time media for various virtual design and construction needs that we have through design, public engagement, construction, you name it. So glad that you're here.
So we were thinking, how could we, how can we get started with an engaging thought-provoking comment or something, and I've always wanted to use one of the famous TED Talks from Matt Walker about the power of sleep, and he starts the TED Talk with, "Thank you. Now I'd like to start with testicles," but that always feels a little too edgy.
A little too edgy
for our presentation. So I'll start with a one-liner that I like from Jeff Foxworthy. It says, "You might be a civil engineer if you think that when the people around you yawn, it's because they didn't get enough sleep last night." Hey. A few learning objectives. What is digital twin for infrastructure? We're going to explore AR, VR applications that we're already doing right now. We're delivering AR, VR technologies within the AEC space right now. Dave will show some examples of that, and then talk about some future innovations around stakeholder engagement. For us, when we talk about these things, we really like to give what we would call a brief history of normals, which, if you've been around alive for more than 5 years, nothing seems very normal anymore. But as a 110-year-old bridge engineering company, this was our normal up until this is probably 30 years ago.
If you couldn't tell, I've worked in that room too. That explains the no
There may be
hair
people
and
in here who have
white
worked
hair.
in that room. Very different, right? That's pre-computer, not very diverse team there, right? All working independently, doing whatever they're doing. It doesn't leave a lot of room for making mistakes, rework, collaboration.
Change one thing and they all give you a mean look too.
Right. And then you see in the bottom, those were some of the most popular tools within that room. The ashtray, the electric eraser. Those are kind of some fun tools. That was very normal in our industry. And when we talk about our normals in the AEC industry, specifically with roads and bridges, we do not put ourselves very steep on the early adopter curve. So this is a very institutional industry that moves fairly slow. It's a big ship. What were they producing, you might ask, on those tables? It looked important. Well, that's it. A very complex plan and profile view of a road. And I mean, if you have no experience in this industry, you're probably like, I have no idea. I don't know. That looks important. What is all that, And that is literally what is used to construct the roads. And when we ask our DOT, Department of Transportation client, for the existing plans for an interchange when we're trying to model something in 3D, this is what we would still get today from them. This is still, they pull these out and they're like, here it is. And we're like, okay. And then we have to take that and turn that into some 3D model before we can really even get into the immersive AR/VR component of it. Fortunately, we're in kind of a new normal, and we have progressed as an industry with computers, computer-assisted drafting, now BIM for infrastructure. So we're now moving into no longer drafting boards, 2D top-down. We're looking at, immersive, more 3D modeling. These are no longer manual calculations that are being made. The design applications are enabling us to do our jobs much better. Also, one of the good things of the pandemic that we think is that it forced our industry specifically to adopt more immersive technologies, simple things like Microsoft Teams for a meeting. Typically, we're a very in-person industry, but because of COVID, we were forced to collaborate more remotely. And so just once our clients started to become more comfortable just meeting remotely, they started to be more comfortable receiving a 3D model instead of a 2D plan sheet. So another just quick example. So that's kind of the new normal where we're at today. It's a really good, we think, springboard, and this is a great conference for what we would call the next normal. And that's really, at HNTB, we have a vision, and there is a huge opportunity, and we heard it in the keynote from Magic Leap, that we do feel like because of some of this more comfort, if you will, with AR, VR, and immersive technologies, the AEC industry is really open for innovation right now. There's a lot of opportunity. We have, just to give you a sense, we have some of the oldest infrastructure in the world, not world, but let's just say our infrastructure is very old, right? And there is a renewed focus on that from the federal governments, state and local governments of we need to invest in our infrastructure. We cannot have another bridge collapse. We cannot let that happen. So we know as an industry we have to do things differently. And that's really Dave and I, taking that as how can we create a vision for the future at HNTB around that.
So as you saw in an earlier slide, basically for us to chart that path forward, we had to look back, what did we used to do? What have we done? What have we done was just prior to COVID hitting, really. And how did that change? How did being forced to bring everybody into a virtual meeting spaces, virtual design collaboration, virtual visualization type of work, how did that change us? So what we're doing now after studying what we've been or where we've been, the pain points for where we've been, everybody's felt the pain points of bad workflows, bad softwares, you name it. We've kind of landed on a nice vision here of how we're going to move ourselves forward using XR technology. So we believe it's going to play a key role moving forward in the design aspect all the way through owner operations, public engagements, digital twin, everything. Our team is really focused on all the technologies now to try to identify solutions in the XR world for each of those phases of a project. So as you can see on the bullet item list here, the ideal is how can we improve these type of workflows that we currently have with XR. So beginning, what is a digital twin? We told you we would tell you what one was. If you don't know, it can simply just be explained as it's a digital representation of an actual physical object, site, project, whatever it might be. And the physical and the digital are connected via data, and that data can be residing in multiple locations. So the ideal is to take the digital twin and be able to do things through the digital twin or that 3D model to be able to affect the physical world eventually down the road. But how are we using the digital twin early in the process? So on the design side, AEC is no stranger to being able to use 3D design models to be able to perform simple type of things like let's find out if we have any 3D disciplines running into each other. Do we have pipes going through structure? Do we have whatever? Trying to use that digital twin to save problems that would typically get found out in the construction field, and that's when they cost a lot of money. So solving the problems before they get to the field, resulting in a better design. But the ideal of taking a digital twin is not to start over at every single phase of a project. What used to happen in our industry is we'd hand us a bunch of plans, those old hand-drafted plans, but then into CAD, we'd hand them off to constructors, and they would actually build a 3D model just to see if our plans were buildable. And then they would say, okay, yes, now we can get true quantities out of this estimation, you name it. But now with the digital twin and all of our design teams using 3D as their design tools, now we have a model that evolves and can be handed off at a certain point to the contractors, and they can move forward. So through construction, and when you think about a digital twin, what's being collected during construction? One, the as-built constructability, or the as-built construction conditions are being captured. Any kind of metadata that you would want them to add to 3D elements for asset management down the road, you name it, can all be collected throughout the construction phase. So at that end, instead of handing over 3-ring binder sets that would fill up a room, of which I've actually done on projects, handing over a project for asset management with 3-ring binders, we can now hand it off in a deliverable that's more cloud-based. Your entire project's in the cloud. Here it is. All the data is connected up with the model. Here's your digital twin. How do you want us to help you move forward with that data? So how do we see XR supporting our vision? As you saw the graph before, is supporting those design phases of the project, but being able to, through design, engage with our clients, design an XR even, being able to go into a virtual space and actually design that space. That could be MEP, piping galleries, whatever it might be. All the way through design collaboration online. If anybody's familiar with the BIM 360 or Autodesk Construction Cloud, being able to create online or virtual reviews, we see XR tying in directly to that. And then through construction, being able to coordinate and design and build as far as going out in the field operations as well and maintenance. So use case number one is this is just a quick VR that we put together for design collaboration. This was a Revit model brought directly into a gaming engine technology. Our shop basically specializes in Unity. Bring in the models, being able to quickly refresh those models as design continuously changes all the time, and be able to place people within these environments very quickly it gives a really nice ideal for discipline leads to be able to, one, review it, but it also starts opening up some pathways, as you see here on screen, of being able to show our clients that, you know, if we work towards this digital twin at the end of the project, we can tie in everything about this design into your asset management databases and be able to do various things with that out in the field or back in the back office if you want to. So this project specifically was the deliverable on this one was made for head-mounted displays. In our case, we use MetaQuest 2s on these. And we also like to do deliveries in web versions as well and desktops. We still in that phase where we know that our clients or the end users all don't have headsets yet. So we really have to start planning for deliverables that can handle all those different platforms.
I would just add to that on the design side, so this gives us the ability to show the design and present the design to our owners in a way that they can interact with it more, but it also provides multiple things. It lets us look at the user experience, which are the travelers. That is very important to our clients, as well as we can apply simulation of people movements, which is also critical. So now we can actually see how we plan for people to move through the space, which is, and do that in an immersive way, and kind of validate some assumptions that we're making as part of design.
Yep. So this project, like I mentioned earlier, came from a Revit model, and all of that metadata that's in the Revit model can be directly accessed and displayed within this environment. In this case, we can control what we wanted to be displayed in the environment. We didn't care about all of the metadata, but we could definitely turn all that type of data on. Next use case is for construction planning. This is a model that we put together for a downtown project out in Manhattan. The design team themselves were curious of how are we going to construct this thing over time? What kind of lanes are we going to shut down if we work through the night or through the day? How is traffic going to keep flowing through this very busy intersection? And in what sequence should we build this? So this was a very, I would say, somewhat simple exercise of connecting up an actual project schedule being used by the typical software engineers use, project or P6 software, and tying or mapping it to 3D objects within a virtual world. And then being able to publish this back out. In this case, it could be published out to the headset, or it could be published out to a web engine to be able to allow the end users, being the engineers, and even the clients, to be able to visualize this. And while they're scrolling through time, be able to go anywhere within that scene and see how it's going to be built at that time. This video is hard to see, but you can actually see traffic movements as well throughout time on that. Field operations, we're working heavily these days on trying to bring AR out into the field with various applications, some off the shelf, some internally on the custom development side, some a little bit of both, hybrid approaches, working with the vendors. But being able to go out and capture full three-dimensional as-built information on underground utilities, say maybe it may be at an airport, it may be whatever the project is, but being able to capture information and then be able to send crews out in the field and quickly find that information without having to go back to the back office and pull out another roll of plans and figure out, hey, where's that supposed to be? Let's take the roll of plans out with the truck and let's go look at it, or let's dig a pothole and see if we find it. That's typically how you find some of these utilities in the ground. This technology is catching on pretty strong. Nice thing about this type of AR application is it's fully integrated in with our Esri or GIS solutions. So all the information that comes with the geospatial information, as well as the 3D models being developed, are all being kind of combined together and accessible through this engine. We're using digital twins also for maintenance. This is another marriage between Revit models, Bentley models, AutoCAD models, some Studio Max models that were even provided to us, but it was a whole consortium of a bunch of consultants coming together and bringing all their model elements for each disciplines together. And then we marry this into a geospatial application as well to be able to take any object within that model and present that or map it to data that's coming from any other type of data source. Could be an Access database, could be a geospatial database, you name it. But this tool is helping us marry those two worlds together. In this case, as you can see, we can slice through the model. The video is a little bit long, but you'll also notice that we can attach different types of data. I call data that's like the typical PDFs or the manuals that you can pull on, or information that's not changing. I call that static data. We're able to connect any application or any model element to static data. But we're also as you'll see in the video here, the ability of connecting to live sensor data. So being able to have a full three-dimensional model connected to, let's say, temperature sensors out on the bridge, or even XYZ tilt sensors that are on the bridge, and be able to visually see this information, whether it's on the desktop or the headsets. And then being able to take that data and say, okay, there's certain thresholds of temperature I don't want to go above, or there's certain amounts of tilt that means I got some problems on the bridge. How do we know that? So it's information like this we can now start tying into automatic notification systems. So if the computer senses, hey, we got a temperature gauge sensor going way too high, we can send automatic notifications back to the maintenance crew and have them automatically go out and start checking things out. Training and education. Earlier in the panel, somebody mentioned Prospect or Iris. This is an application that we've been working with on Autodesk. It's called Autodesk The Wild. It's kind of a sister product of Prospect. And this was a tool that we tried out to be able to say, can we get a lot of people in the same room and be able to collaborate on various types of things? So this is an exercise of going into a workspace first, and being able to go up to virtual boards, talk to each other, see somewhat hand gestures, and then be able to use almost a whiteboard type of element to be able to place things on the whiteboard and plan things out. In this case, this project was for designing or planning out a hurricane evacuation service plaza along a turnpike. So the ideal in this room is we have trainers in the room that know how to deal with these emergency situations, showing a team within that room, here's where we're going to place volunteers, here's where we're going to roadblock things off, you name it. But not only within this space, there's another video that's somewhat long, we're able to, within this space, you'll notice that there's a 3D model on the back side of the table behind us. And then that 3D model, you can click on that and go directly into that model to get your first-person view of walking around. So if you were going to staff this emergency hurricane evacuation site with volunteers who have never seen this site before, putting them in an application such as this, whether it's via headsets or the desktops, and letting them walk around the site, letting them be able to see, okay, if I have a volunteer in position number 1 or number 3 like you see here, what am I going to see when I'm physically out on the site? Am I going to be able to see that person easily? Am I going to be having some issues? So this was a really good tool for the actual client to plan out the site, because they can manually place these positions around the site, hop into the site virtually in 3D and be able to say, yeah, you're right, we're not even going to be able to see the person in position number 3 based on the trees that are in the way or the building that's in the way, you name it. And last but not least, on the use case, we do a lot of public engagement type of work as well. In this case, this was a project that we put together almost directly during the COVID pandemic. And we had a very large project at the time where we had to present or have a public engagement meeting during a time nobody can get into the same room. A big problem, right? Especially if you need public feedback on a big project where you're taking a 4-lane highway right down the middle of a city, blasting out residential houses, whatever might be in the way. How do we get their feedback if we can't get them in the same room like we've been doing for the last 100 years at HNTB? So we worked with a technology called Amazon Sumerian. It was basically an avatar that you could give scripts to. You could have it answer questions. You could make them bilingual based on how you were logging into the website itself. And we could tie that virtual space, allow the users to be able to click anywhere within the room, get more information about that project. And if they wanted to provide feedback, they could just click on a little area within that room, fill out their forms of feedback, submit it in. And next thing you know, we found ourselves with a much broader audience of public engagement than we had ever imagined of having in a room together. So this was a good exercise of showing by how you can, when you can virtualize these types of environments, we can get a lot more involvement from the public and get a lot more engagement and feedback from them, something that we weren't used to when you could only gather about 50 people in a room.
And yeah, this one specifically, that room is there on purpose. That is the physical space. So they had a physical public engagement space where the public could go and interact and find out project information. So we modeled that space. It is that space.
Yeah.
It's just modeled in 3D.
So I don't know how quick we went, how much
No,
time
I
we
think
have.
we're good. We got a couple minutes left. I think I just would close once with thank you for joining, everybody. I appreciate it. And I think one common theme maybe you heard from us that I think it's important on, at least for our XR journey, is be open. We showed probably 7 or 8 different software and solutions there. Like things are happening so fast in this space. There are new people coming to market all the time. Like, be open to trying new applications, you know, and try not to lock in on one thing and make everything work. I mean, for us, that's what's been successful, is being open to trying new tools.
Yep.
So thanks. I think we have a few
Question?
more. Thanks.